So last week, we started off by um, first understanding what SQL is, a structured query language, and then we talked about the different type where we talked about the relational and the non-relational databases, and we talked about tools that could actually help us navigate through the waters of either database. And we said database are very essential, and these are something that we we use to actually organize. I mean, the collection of data, storage of data, and data management, then data retrieval. Because if we store data, we want to at some point retrieve data. So, and I believe we were taken through the point where we saw the concept of the relational database, which is just about the rows, the column, and the rows represent individual records, while the column represent the attribute, that is the feature of that particular column. What that column is talking about. There you have something like movie name, movie title, year produced. I mean, those are attributes, and those are what the column stands for. We were able also to see primary keys and foreign keys, and these are very essential when we're trying to retrieve data. And they don't just play role while we're retrieving data. They must have first been declared when those tables are being created. And we saw the different relationship that could exist between um, tables in a database. So we saw the one-to-one, we saw the one-to-many, and we saw the many-to-many relationship. We also saw something around the basic queries, because we did some basic queries, and we saw the classification of this or the categorization of these basic queries, or the data language. So we have the DDL, which is the data definition language. We have the data manipulation language, and we have the data control language. So these are the classification of these SQL commands, which are actually the queries that we'll be writing. So some are actually the data and definition language, and we have the data manipulation language, and we have some that falls to the class of data. Sorry, I just lost power. Just a minute. Okay, so like I was saying, we have the data definition language, we have the data manipulation language, and we have the data control language. So today we'll be getting into the business of the day. So the business of the day will see us doing some um, just having our hands about joins. But before we move into join, we'll quickly just run through what we did last week. Okay, um, in a minute. So I'll be sharing my screen back. Did anyone recall how we're able to get the diagram last week using the reverse engineer, and how we're able to load data into our SQL by creating it ourselves, and then also by loading, an already built database. Okay, all right. So this is what I'll do. I'll drop this database just for the purpose of this class again. Okay, let me drop it. So drop now. So I will also drop this. So let me see what we have in the tables so that we can recreate it. So we have student ID, student name, and student email. All right, so we will be recreating that. So I'm dropping that as well. Okay, so now remember, like I said, and this is just for everyone that missed it last week while it was being demonstrated. And what I mean is that in case you miss how we created from scratch and how we brought in, how we loaded the database, I mean, that we have on our local machine, and then we load it into the SQL workbench for us to work on it. So the first thing is this. So we built something from scratch, and so I'll just be taking you through that very quickly. So just like I said last week, it's very easy. The language is very easy and very easy to use. So and the first thing you want to do if you want to create um, if you want to create a database or so the first thing you want to do is just to create the structure and the structure or the housing of this setup database could actually be referred to as a schema. So this schema, which is more like what the database looks like. I mean, and it is sometimes interchangeably used as a database. So it is we can use without having to write anything, and that's why one of the reason I love my SQL workbench, because it gives you some, I mean, um, click and play option, so to say. So by clicking on this particular icon, so it says new schema. So but we want to name our new schema um, tech in transit database. I think that was what we named it last week. So tech in transit database. And mentioned something about naming convention. I mentioned something about naming convention last week. So I spoke about how space should not be used, because by the time you use your space to separate two words, it will be classified as two words. But you want to have every declaration as one word, and you don't want to have a space in between. And if you want to demonstrate a space, you can use your underscore to demonstrate a space. Why? Because we have functions that are built. So if um if you have a space and those words are standing on their own, um, well, it could be taken as though you are declaring a keyword, and these are very similar in what we see in Python. And I'm sure we didn't take Python in this cohort, but um, so by the time you playing around with these languages, you should be very careful about space, most importantly. So you can choose to use an underscore, even sometimes even advocate against hyphen. So you see that you use underscore or you capitalize each word. So that's, I mean, and how you capitalize each word is like, say for instance, I want to name this John Lawal. So what I would just do is to say John Lawal, because I don't want to use an underscore, but I could as well say an underscore, and just to distinguish it. So you can choose your style, but I want to tell you, you won't go wrong with any of these two options. Either you capitalize each word just to know, um, say for instance, the the employee database. So let's assume you just must put it this way, like it must have the article D and it must be like this. So just to distinguish that um, the first word ends at E, then that's the first E. So you want to introduce a capital E to introduce the next word, and you want to introduce a capital D to introduce the last word, which is database. So this is a way to go about this, and another way to go about this, you could actually have it as underscore, uh, just because by the time you were calling this particular database, and if you had put it at a space, but one good thing about MySQL Workbench, it, if you then come here at first, if you are declaring, so let me copy this so I won't have to do that again. So if you at first you try to use a space, it goes back to the beginning, just telling you no. But by the time you have spelled it out, and you come back and you say, I want to put a space by default because I have words there, so it will allow you. But by the time you want to create this, you might run into an error because that is what it should do for us. But even if it doesn't do that at the point of declaration now, we possibly might run into an error by the time we continue. Okay, all right. So I just refreshed my screen because so I'll advocate for an underscore and capitalize word if you don't like underscore. Some of us don't like underscore. Some people do. So if you don't like underscore, you can capitalize each word, and I think that works. But I think what the name we want to give to our database is um, tech in transit database. All right, so tech in transit database. So now we don't need to write any code, and so we'll just say apply, and it brings this dialog box, and then we say okay. All right, so this is what we could have written if we had to write anything, and we just say apply this create schema, then the schema name was provided tech in transit underscore database, and I mean which reads tech in transit database. So please don't read when you're reading the name of things like this. Please don't read underscore with it. Just say tech in transit database. It won't be professional to say tech in transit underscore database. All right. So we have that already. So I don't need to do that again. And that is done there. Okay, so the next thing that we did is that we now know that we have a database, but our database, we have, things that we could see in the database. We could have our, the schema, that's the structure, right? Like I said, this is a structure, and, things that we can see in there. We can have tables that have all the data, and we can have different tables. We can have views. We'll be talking about views in subsequent class, and we can store procedures, and we can have functions there that will be using. And okay, so it is grayed out. So to create a table in this database, so what we could do is actually first to declare what table do we want to create. So let's say we want to create the table employee details. Okay, we want to create the table employee details. And to do that, we first have to declare what the table is, the name of the table, and then we define those items that is the feature or the attribute of the table. So the columns that will form the table. So let me do that here now. Okay, but before you do it, but good enough that tech in transit database is um, highlighted. But in an event where it wasn't, let me see if I can get it not to be highlighted. Okay, okay. Okay, so one way I could do that. All right, so let me leave this. But in a case where this is not highlighted, right? So you have to highlight it for this workbench to know that you want to work on this particular database, because you might have several couple of them, and we'll soon be having a couple of them now. So yeah, now we want to write our code. We want to write our code, and then just to create a table in this database that we have in this scheme. So we say create, and I mentioned something last week about um, respecting the keywords by capitalizing them. There are no rules to that, but just good enough if you have the blue color calling them out. So, but you possibly just want to still capitalize capitalize it, and then, just to distinguish it. So let's say student detail is the table we want to create. Um, yeah, students details. All right. So we want to create student details. So it's asking us what should be in student details. So we said we first want student ID. So want the student ID, and then uh, we need to tell um, because at this point where we are defining, so we are defining what this table should hold. So we want to define what data type should this student ID be. We said it is um of the type integer, and that int, that is, it should be a counting number from 1 to um, infinity. And we also want to make this a primary key. Remember the other time we were talking about primary key, so that as good as they had, the first must be declared. As good as they had, the first must be declared. So we've declared this to be a primary key, and then the next we say we want to have the student name, and so we want to have the student name, and we want this to be virtual. And remember what I said about virtual, that you want to sometimes limit the character by saying, oh, I want it to just be a maximum of 50 character you'll be able to provide. I don't know the person whose name is longer than 50 character. So we might want to even say full name. So full name. So right. Okay. So and then we want to move on to, let's this person provide his or her email address. So student email, so that we'll be able to communicate with student via email. And then we say it's of the type virtual as well. So, and let's make the email as much as on. So let's limit it to this, and then we say that's the end. That's what we want this table to contain. The student details table that we're creating, because we have said create table, that's the keyword for creating a table in SQL. And we said create table, student detail is the name of the table, and the table should contain student ID. But the student ID, we need to define what type of data type it should be. We said it should be an integer, and we said it should as well serve as our primary key. And also we said we want the student to be part of what we have in that particular table, and we also want it to be um, the data type to be of virtual, and then we want the character to be limited to 50 character, and we need the email address is to be able to accommodate you. So now at this point, what we should do is to run. So we'll be running this using this thunder sign. All right, so and it ran successfully. So if I should refresh this place, I should have my table now having a drop down, so I can then pull this drop down, all right, to see the table I have just created, student detail, and then I have all of these. I have the columns, so I can then check my column from this place and say this is the student details. I have the three columns. The first is student ID, student full name, student email, and stuff. So now we've been able to create a table within the schema that we created initially. So now the table is empty, because if we should try our hand on our um, if we should just try and um, run the very fundamental code in Excel. I said just now in SQL. I mean, that is select just to see what is there in the table that we have just created. We say select everything from, and then we call the table name. So you can call the table name this way, or you just type it out. So I just felt we can just type it out. So now we're running this. So we can highlight this and run. So if I run this now, so now it gives me the table that we created, and the table, we have the student ID, we have the student full name, we have the um, student email, and but the next row, I mean the only row that we have there is all null, 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 and that means we don't have anything in our table. We don't have anything in our table. So how do we go about this, ensuring that we populate our table, and that we might we might end up having something in our table. So now let's do that, and then insert some things into the table. So now we've come this far. So any question, just any very fast one. Okay, so let me continue that. Then let us insert stuff into what's it called? Into um, our table. And how to insert things or bring data into the table is very simple. Remember, I said SQL could be being a fifth level, a fifth generation language. It's has very closeness to it, just like we saw what is on the screen. Create table, and that simply means we want to create a table, and then we did the definition. Select, and remember, asterisk means all. So select everything. Basically, select everything from student detail. That means give me everything that is in that table called student detail. It is as very simple as that. So now, and the next thing we'll be doing is also very simple, because we want to insert data into the table that we had created. So the keyword for that is to insert into. So insert into. So where are you inserting into? All right. So insert into this table, and then we want to check what do you want to insert. So the first thing we want to insert is the student ID. Student ID, and I also want to insert the student full name, and I also want to insert the student email. I want to insert the student ID, the student full name, and the student email. So now the next thing asking me is that what are the values that I want to provide. So I'll just say the values now. Values. So insert into the student and then what do I want to insert? I have put in, because you don't have to. uh, Maybe I should take the ID out, okay, and see what would happen. So you don't have to insert everything. You don't have to call. You don't have to insert entry into everything, every column that you have in your table. So this place just tells you, because if I write everything now, it might be taken as anytime you want to insert, you must insert everything into the table, okay? But you don't have to. So I just remove the student ID from there, and then I'm declaring the value. Remember, I've removed the student ID, so I won't provide student ID. So the values you'll be providing are the values you want to insert into this place, okay? The values you want to insert into this place, all right? So um, now, the first value I want to insert being the name. So just taking the name and then paste it here. But remember, being a string. So this is a string. So we have to comment it. I mean, not comment now. So we have to put it in an inverted comma. We have to put it in an inverted comma. So anytime you put in for a string, just for the language, or I mean the environment, to know that this is a string, so we have it in an inverted comma. But emails, I said email, numbers can actually be inserted without having them in an inverted comma. But for strings, so please don't forget to have them in an inverted comma. All right, great. So, and the email address should then be giving him an email address now. Uh, so I remember this is also a string, so we just want to comment it out and then we are good. Okay, so if we should run this, we should be good. Okay, also been an error. So where is this coming from? Okay. Why is my you you have an error? So oh sorry, let me do this and see. Why am I having error? Just a minute. Okay. Let me try and bring in my. Let me see something. You shouldn't be holding me for my primary key, but let's see something. No, just something I didn't type well. So wait, let me put all of this in a new shade. I think that could be the issue. All right, it's not allowing me. Okay. But why is it not allowing me run different codes? That's serious. Okay, so we have no issues. Just I've taken it out. All right, so it's flagging my student ID, and I want to bring it in as insert. I mean, as an update. But let me just have it here. I don't have ID there. Why is it flagging it? Okay. So it has accepted it and it is now in the. So now if I should run my select, um, so this should give me this, and then I have student ID as one, and I have Absalam Habib, and then his email Absalam Habib at techintransit.com. But now I discovered that he has not been given an a tech in transit domain account, but I want to quickly change that email address and then give him uh, that email address. So without having to delete the entire entry and say, oh, let me give him another email address entirely. I mean, another row. So I will then be putting in the value another time. I will take out the row one. That's the entire row for Absalam Habib. But instead, I want to update it because maybe we'll discover mails sent to this domain were bouncing because it has not been set up for the transit domain. And then we want to just update. So if we are to update this, then okay, so that we don't face the same thing for a regular time for it tomorrow. And then we say we want to update. Just trying to see that I mean it is as simple as this. So we wanted to update an entry in a table, and the keyword we're using here is update. So we do update, and the table name that we want to update, I want to update this table. Um, we're updating this table, and then what do we want to update in it? We want to set um, the student email. We want to set it to do I still have the copied? Uh, we want to set it to this. So we want to set it to that. But if we just run this, we might run into an error. Oh no, we want to set it to something else. This is what it used to be. Let's assume it has a BBTeX domain. So let's assume it has a BBTeX domain. So now we want to change it to this. Well, if we just run this, we have actually not informed, given a very full instruction, because if we have several items in that table, so it might mismatch. But we want to restrict it to where the condition that we're talking about. So we use the where um, keyword. So where keyword is like a filter. So now we want to filter to um, what the particular entry we're talking about. So we can use our ID, that's where the student's ID is equals what the student ID was is 1. Okay, so where the student ID equals 1. So by the time we run this, By the time we run this and then we come down here and do our select asterisk from there. So we should have experienced a change of email address. So you can see this that was carrying um, Salam Abib at techintransit.com now reads Abud Salam Abib at bbdex.com. So I think this was some of the things we did last week before we went into trying to see what a sorry for the breaking transmission. Like I was saying, so we've been able to, I mean, just do a recap of what we did last week. Now we will then, this we also did last week, bringing in data from, I mean, a ready database. So we did load this particular database and then we bring it in. So all we need to do is just to hit the run button and then we have a new here. So we have a new database called the classic model. Okay, so we have the classic model ready for us. So on this classic model, we'll do a lot of things. On this classic model, we do a lot of things. So um, and just for a show of what the table looks like, I mean, what the database looks like now. So we might want to first just inspect it. So how many tables does it have? So we can actually do that without even running any code, without writing anything, using my SQL workbench. So coming here, we can see all the tables that are available in this particular database called classic model. So classic model. So we have customer, we have employee, we have offices, we have other details, we have other payments, payments, product lines, and we have the um, products. So we went for them and say we possibly want to see what is happening in it. So and the same thing we use, and one of the things that we will do the most is actually to select. So select is used for pulling details from a database, especially from a table. So it helps you to pull it helps you to retrieve. It's actually used for retrieving. All right. So now if we do select, so from I think now if we able to select as from any, so we have the customer name, customer number, customer name, contact last name, contact first name, phone, address, and so in that particular table called customers. All right. So now that we see all of it, then say that we want to. Okay, so now let us do something. Let us. So we have a lot of city. So we can. So we have a lot of city. I just want to check the duplicate. So I mean, this is because you can just go. So let us just check for all the NYC. All right. So now, so we want to select all as well from the customer, but um, your boss just called you and said, please uh, get me the customer details for all customers in New York City. That is NYC. All right, in New York City. So I mean, you don't have to be going one after the other, and that is where you so we wear it, and then we say where city, okay, where city equals what now? New York City, from New York City. So um, okay, so now we can also filter with any of these data. Okay, it could even be the credit limit. Maybe these customers want to do a part payment purchase, or they want to have a buy now pay later, and you want to see what is their credit limit. So you want to see shoppers with credit limit not less than say um, 15,000. This should be denominated in USD. So you can also still do that and then go on and on. But much more than just working on a table, it is very easy to work on a table. Where it gets very complex is when you have to um, get information from getting information from across the table. All right. So we have all of this in place. We have information from the customer here. We have um, individual tables that are contained in these classic. Just a minute, please. All right. So, like I was saying, um, now we can then, yeah, it's very easy. You know, you can do a lot of things within this space. Just what's it called? Um, just referring to a table. So it is always easier when you have all of that, because all you need to do is just to think about how do I get these details, because you might be giving um, several conditions. So now it's new and and credit limit less than say 15,000. Okay. So if we run this, we have just one person, one cost. Oh, we don't even have any. We don't have anybody that's fulfilled that. So let's say it's from, and let's change the direction. That's and credit limit greater than 15,000. So we have this much people. So you can have conditions that you will filter with. But like I said, it is easier when you're running all of this within a sheet. I mean, a table. But now you want to look across tables. You want to look across tables. And the first thing you want to know is to see what is the relationship between these tables. You want to see the diagram that shows you how these tables relate with each other. And if you don't because one of the lot of works that you might want to do if you don't have that diagram is to then get all the table headers for each of the table in this database, and then you want to know, just be looking at it by yourself, or maybe querying the formation of these particular tables and saying, oh, which one is this, which one is that. But there is a diagram that we bring it um, just bare before you without you having to do that as well last week. Okay, now, so we'll be coming to this point. We'll come into now database. So we come into database and we're using the reverse engineer. So we're using the reverse engineer. So when I click on it, so I'll have a pop-up to provide my password, which I'm doing now. Okay. Now, all you need to do next is just to next. Okay, selecting the appropriate schema you want that to be applied on. So execute. Now, okay. So now we have the um, diagram here. We have the diagram here before us. So with this, we can know which table link to what. So, and without having the understanding of this, implementing joins will be very difficult without having the understanding of what how this table connects with each other. Implementing joins will be very difficult. Implementing joins will be very difficult. So now, at this point, we'd like to then go into joins. So now, one of the places I would like us to implement joins is, let's see the relationship. Let's try and get some data out. Somebody's trying to suggest by the relationship. Anybody suggesting something? All right. So building, now we want to get customer name now, and we as well want to get um, the phone, the office phone number. So now, so this is it. So in this place, we have the customer phone here in the customer, and we have um, the office. Yeah, I believe we do it. So yeah, office code. I see that. Yeah. Wait, we can through. Okay, so all right. Yeah, I can see everything. So now, oh, okay. Can you see? So you have to be very careful. This does not connect to um just a minute, please. Okay, so you have it bigger now. So so you have to be careful of your connection. So initially, I was seeing a connection of this connecting to office. So whereas, because I was puzzled that I couldn't see any connection, but it wasn't connected to office. It was because this the arrow went behind the office box. So it was actually connected to employee. All right. So now, so and what they connected on, I mean, what they have in common is the what's it called? The employee. Um, so you could see what they have in common. They have the employee number, and the because the employee number is represented in the customer table as sales rep employee number. So, but on the employee table, it has the employee number. So now we can then pull the first name and the last name of the employee that serve people that live in 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 New York City. You know that information is not in this table. The only thing you have in the customers table is the sales rep employee number. All right. So that is remove the sales rep. It is classified as sales rep because it is on the customer table because they are the sales rep. But let's take them as the employee number. We are looking at them now in-house. So we want to see which employee serves people from New York City. All right. But to know that on the employee table, there is nothing like customer there. And there is nothing like the state where the city where the customer is situated, but it is contained in another table called customer. So now that is where join plays a role. So you want to put the two tables together, you want to join those two tables and make them one, and then um, so that you can get the information that is residing in both of them. So and how do we go about this, and that is what we will be talking about in very quickly tonight. I haven't gone through that. So we have different types of joints, right? We have the inner joints, all right, and you might want to take note at this point. We have the inner joints, and what the inner joints does is to um, return the records that have matching value in both tables. All right, it returns the record that has matching value in both tables. If you want to classify it, you could be classifying it as your intersection in set theory. Remember that set theory, the Venn diagram. Sorry if that is not familiar. So you want to um, think it as an intersection. So because it's by the time we do inner join, so it will return the record that has a matching value in both tables. All right, in both tables, and we have the left join. So left join, what left join does, and left join is something that, and when we're talking about left and right join, it talks about how you order even your code or your expression in SQL. So by the time you are writing out the expression in SQL, you're writing the queries now. So if you put a table first and then the table, another table next. So the first table is actually the table on the left, and the second table is the table on the right. So if you want to do a left join, the first table take precedence. So it returns all records from the left table and the match record from the right table. If no match, null value are returned. Okay, it returns all records in the table. So if I'm looking for something now and now I'm joining over customer and employee, please pay attention and activate your very good mind. Okay, activate your mind so as to just follow the pictorial representation of what is on the screen before you, So now, let us assume I have declared customer first. So by the time I am calling them in the query, I called customers first. That is this table called customer. I called it first. That makes it my left table, all right? So, and if I call employee next, that makes employee the table on the right. So if I now then declare a left join on them, so what I'm saying that return all value that matches it in, that is, it returns all the record from what's it called, from table on the left, that is every record here in customer. That is all I just want to do. In addition to all of this that I have in customer, I want to add what is matching here to it. So, and it will add it at the end of it. So now I will now have this, the whole of customer plus what we have here. So if we are to represent it on the Venn diagram again, then that is the set that we have that will cover the first circle, the circle on the left, and it will end at their intersection point in the in, that the intersection of the two what's it called, the the two circles. So, but we get to practicals now so that it won't just be imaginary. So, and the same thing goes for right join. So we have the inner join, the left join, the right join. So right join now, the right um, table takes precedent because it returns all the record in the right table, and then it's also and the marked record from the left table. So, all right. Let's quickly take some example, and then and we can have something called a full join. So the full join is just like um, union. So full join is just like union. What that does is that it takes table A and table B and bring them together. So all the records in customer will be will be um, will be pulled, and all the records in the employee will be pulled if we're using full join. So that is just more like union. So when we say A union B, that is records in A and records in B without duplicate. Okay. All right. So now let's take some very good examples. So we have given ourselves a task now that what we want to do is to get um, the employee, okay, the employee, the first name and the last name of the employee that serves the customers that are from what's it called, from New York City. How are we going to pull that? So let us see. All right, so let's get back to work. So now, so we can always come back here to see our table if we run into anything. And just a minute, please. All right, so sorry for the break. Okay, now we've given ourselves a task, so we want to put the employee that is serving the customers. We want to put the first name and the last name of the employee that is serving people in New York City. All right. So now let's get to it. So we can take this out, or let's write a new script. All right. So first, and I will then have to infuse another concept that we use in SQL when we're writing when we're writing queries into this, and that is the concept of alias. So I will explain as I go ahead. All right. So I will explain as I go ahead. So but let me first do the full and. Yeah, let me first use the full and before I then start using the shorthand, which includes the alias. All right. So remember, our task is to select. Okay. So we want to select um, employees, and I will explain this shortly. Employees dots, right? Last name. So where is the dots coming from? Right. Remember, we're about to join two tables. So because we're about to join two tables, everybody should just like the ongoing Olympics, okay, you will see all the athletes, we have their country badge on them. So this is just what we're doing here. All right. So it is last name that I needed. We needed the last name, but we needed it to bear the table it is coming from. So we need to say the table it is coming from dot last name. I think you saw something like that when you're writing DAS in Power BI. You must have, if you have been paying attention to the Power BI class, when you're writing DAS, you will, what's it called? You will have seen something like this where the table and the column. So you have a similar expression, but you know it is that is the table, and then the what's it called will be the column name will be in a square bracket, and you know and write other expression. But that is the same thing that is happening here. So we are making the table, then dot the name of what we're looking for in that particular table. I think that is clear. So, and why we're doing this is because we're about to join two tables. Because if we just declare last name and we then go down to do joins, SQL will be puzzled that where should I be looking for last name from? But we had already told it by this expression that look for last name in employee table. All right, I think that is well understood. So we also need employee dot first name, right? We said we needed the first name and the last name of these people. And what other things we can get as much as possible. All right, we can even get the that is employee number, employee dot employee number. So we can get the employee number, and then we still get employee, okay, dot this. All right, and we can get other things from this other table called customer. All right, so we can get some other things from here also. Yeah, we can get um, the city and credit limit, but now you know the music will now change in that whatsoever will be getting here will be prefixed by what? Will be prefixed by customer. dot so we said we want to get say the city is not bringing it for me. Okay. Customers. Okay. Dot city. Okay. So I want to be sure. And then um say credit limit as well. Okay. Um credit limit. So it's customer uh dot credit limit. So now we have all of that that we want to select. Okay. We said where are we selecting it from? So we're selecting from now. So and this is where it's so because we're using the inner join, which will end up being an intersection. So we can declare any of them first. All right. So we can declare any of them first. But let's start with in this case customer. So from but if we are doing left join or right join, we must be very sure of which one should come first. So we're doing this from customers. So pay attention here. All right. So then we are declaring an inner join. So inner join employees now. Okay. So on what are you joining these two? All right. On what are you joining these two? So I am joining them on right on the thing that is what's it called to both of them. What the link between both of them? Remember in our diagram, in case you've forgotten, let's go back there. This is the link between both of them. The sales rep employee number, and in customer table it's regarded as sales rep employee number, and in the employee table it is just employee number. So this is what we are joining them on. So this is the ground on which we are joining them, right? So we're about to do a marriage for these two people, and the ground based on their confession that they have these two in common. So then we now proceed to say uh, on customer remember that we have a duty to make sure they bear the name, the right name. So we did customer dot now. What's that in customer sales rep? Yeah, there you go. Equals um, so sales rep and then the name in the table dot employees number. All right. So this is on what we are joining them. But remember, It didn't end yet. If we run this, all of this will come out. But remember, we wanted to limit them. Or maybe let us run this and see what will happen. So if we run this, what will come for us is that literally maybe everything will come up. Everything will come up. But we wanted to limit it to only, we said we want to see employee that is serving our sales rep to people living in New York City. So that will have been the next filter we would just put in. And somebody in the chat, please, what is the keyword to filter? Yes. All right. So, yeah, where? So if we introduce the where filter and we say where, what is that? That is customer dot city is equal to NYC. All right. So if we want this, this is what we have. Remember, we asked for the employee number. We called for the last name of the employee. We would say the first name of the employee as well. And then the city from, remember the city is from the customer table and the credit limit of those customers. So if we want to do more, we might do more by adding something here, maybe the customer name or the customer something details, some other details. And that's what I'm saying here. If we remove this beautiful guy, that's meaning my guy supply. If we remove it and then run this, so we will have more entries because we'll be having for everybody. Okay, so we can do more. We can increase the what's it called? We can increase the number of things we're looking for. We can then include the even the customer name. Okay, all right. So, but we'll do that shortly. Um, okay, so let me include the customer name here so that we know that the customer information starts with the customer name. So we can do something on customer um, dot customer name. Is it looking like Greek? Please confirm in the chat box if it is looking like Greek. One if it is looking like Greek. Zero if it is not. One if it is looking like Greek. Zero if it is not. Where is the chat box? One if it is looking like Greek. Zero if it is not. So and that means it is neither looking like Greek nor not looking like Greek because nobody is saying anything. One, it's looking like Greek. Oh, wow. So, yes, look at the syntax on the screen and understand that you have done a day's job or you have even done, a daily. This is what some people do every day and they earn a decent pay for it. In case you don't know what is before you now, is something somebody does every day and he earns a decent pay for it. And if he introduces himself, he will introduce himself as a data analyst or even a data engineer. And when you hear such introduction, oh, tech guy, you don't know tech bro. This is just it. I mean, deeper than this because we need to first even know how to pull those information. And that's why sometimes what I do here are spontaneous. Why? Because let's just throw something here because it will never be a straight jacketed scenario in the workplace. Uh, I don't like, oh, we just come, do some exercise. Let us think and give ourselves a problem and then we solve it. Because it is the same syntax, you just need to select is our big boy in retrieving data. And from is his best friend because select all of this and just breaking it down, going over it again, is that select a keyword for retrieving data and we're not saying that see this is what we need. Okay, this is what we need. If we are not using join, any type of join, and we won't have put this, we won't have put this table name, we won't have put the employee dot table employee number, no, because that's the table name. This is the place for the table name, and this is the place for the column, right? So, but because we are using a join, so we have to, and joins implies that we are joining more than one table together. And in this case, we join two tables. Let me tell you, you can join three tables because it could be that by the time you join this, you have not even gotten to where you are going. And I'll show you an example and continue to explain this for you. Take, for instance, what I'm looking for is, let me see something here. All right, good. So, employee is linked to table. I mean, it's linked to office, all right? So let me see an information that is not in employee that is in office. All right. Office code, office. Okay, good, good. So I want to be sure that the employee that is serving people in New York City is living in New York City. All right. Maybe I want to check what city is this employee that is serving customers who are in New York City. What city is it? Because we might be doing an investigation and say, oh, this person is not always, let assume is to go and the sales rep, let assume he needs to go to their house to deliver those items. And a report has come that some of our sales reps are not always prompt. We want to check what state is he even coming from, or what city now. Let's use city since where we got New York City was city in the customer table. This employee that is servicing them, what city is this employee coming from? So the city is not here. You remember that these two are joined together, and that's the join that we have just done. So, but the information I'm looking for is not here. The employee city is contained here in this office. So now I will join these three tables. One that is customer, employee, and office for me to get the city where the employee that is servicing this customer stays. Complex. I am speaking, I have complicated everything. I repented from going that route. So, but my point is this: you need um, you need to be able, and that's why I will always tell you this diagram is your best friend whenever you want to use joins. I mean, I've adopted it as my best friend whenever I want to use joins because it shows me the pictorial representation of anytime I want to use join, I would demand for this. Let assume it's a database I don't know. And I remember when during my data science days, I will always request for the diagram. Please give me the diagram before I run, because we're even using this space. So I will request for the diagram, and then once I get the diagram, forget, I can join 10 tables. All I need is my mind just to be following. Okay, maybe I'm looking for something here, here, and to get to there, I need to join 10 tables. You can join 10 tables, like join all of them together. And all you will just be doing is what we have done here in joining two. So you will just be doing from this. So the next thing we will do is inner join another table, then we'll just continue joining and joining and joining like that. All right, so I was just trying to explain this because I want to quickly touch on alias now. So remember, also known as this. So if they say aka, I know some people will say my name is John Lawal, aka JHL. All right. So in SQL also, so that we won't because why this seems to be too long is because we have written too much of things, and we couldn't even get the it in a very concise form, but we can by using alias. So now what I'm explaining is that this is what is important, those words after the dot, and the words or the tables before the dot is essential. So because we are having two tables now, so we want everybody to bear his father's surname. If I will just put it that way. So consider this that comes before the dot as the surname of anything that comes after it. And what I mean by surname, this is the table in which customer name is contained. Employees is the table in which the first name is contained. So first name could be contained in customer, but I am telling it I don't want the first name in customer. I want the first name in employees, and that settles it. So now I hinted on something just now, that I want to make this a bit smaller, and so that it won't be too big, because we have a provision for that. And what we can use, what we can do to achieve that is by using the alias. So alias, just like I jokingly say, my name is John Lawa, but I can say AKA JHL, also known as JHL. All right. So now we can then do that now. So let's quickly do the alias, and then we move on from there. All right. So uh, to just bring alias into this, now the first thing I want to use. So you declare alias on those tables, and also you can declare alias on what you want. Remember, look at what this table looks like now. See, employee name, employee number, last name. You want to put it in the format you want it. You don't want it to be joined together like this. You want to write it well. Look, this city now, nobody knows what city it is. Take it for employee city, whereas this city is actually customer city, and this credit limit is also customer credit limit. So you want to clarify that, and you can use alias to actually achieve that. And also, instead of me writing this employee in full, I can use alias to actually do that. And how we declare alias is um, where we declare the table name alone. So we can say this, I can say this customer that I am writing here, I can declare it, I can give it C as alias. That is how to declare alias, also known as. So customer will therefore henceforth be known as C anywhere in this particular query. So if you see C, if what's it called? If SQL CC, or if this my SQL workbench CC in my query, in this place, it will regard it as customers, as table customers, because it is table customers that I have alias as C. And I can do the same for employee, and I can say, please regard employee as E henceforth. So what that means is that I don't need to write this in full any longer. Okay, don't worry. Now, so it works, right? It works. It works. So now I want to still do something more. I was talking about this my table header that it is not giving me what I want to see. Like this one, especially this could be misleading. And even the first last name and first name could be misleading. And somebody might think um uh, it is customer name, and we might be even we might start arguing that why the first name is this, the last name is this, why the combined name, why is it showing another name, not knowing that this side is employee name and this is what we have as the customer name. So we can also use alias to put it as we want it. Okay, we can use alias to put it as we want it. All right, so now I said something about um, space the other time, that when we are declaring anything, we should be careful of using space. But we can actually, under this alias, if we want to embrace space here and we want it to appear how we want it, all we just need is to um, regard it as a string and say this is, we can just say, we can change the employee number that is coming, and we say it is employee ID, employee ID. Okay, and this last name, as employee last name, and the same thing we want to do here as employee first name, and also customer name. We don't want it to be joined together. We want to alias it as customer name, because this table, you remember, we will export it. We want to share it with people. We are the one that understand how the table structure looks, and we can work with it like this. But remember, we want to share it with people, those that we have it on CSV file or Excel, and that we just do they will just use the report. So we want to keep them. Okay, so now um, I've gotten to city. All right, so I'll just say this is this is the customer city, right? Customer city. Okay, and this is also customer as customer um, credit limit. Okay, right. So we have all of this in place. We can then slide to see that everything is correct. So now we can now run this. All right, so look at what we have now. So what we have there before was the default column name for those columns. So what was declared in the database. And mind you, what we just did now will not change what is here. The column name for customer name will still remain customer name as it is like this. You know, customer name without is still what is here. Small letter C starting it. It has capital N just to show the beginning of another word. So it is still as it is, right? So, but in our table, because this is what we want to see as we have it showing this way. So now, and for every other ones. So now we can be sure that nobody will mistake this for employee city. Rather, they will be sure that it is customer city. And this last name and first name, we're now sure that nobody will mistake it for customer name. They will know that this is the employee servicing this customer. And this credit limit isn't for the employee, but rather is for the customer credit limit. So, and that is it. Oh wow, doctor, I don't mind me. So this is what we have today. We've talked about joins, and we've also talked about um, alias, and you know how good it is to our work and how it makes it helps in reducing repetition because, say for instance, since we have declared customer as C, so it has reduced the repetition of us having to write customers in full, and same thing for employee. And you know, and when it comes to our table header, we're able to define something that helped us in, I mean, cleaning up our space and putting our data in the right format that we want it to reflect. I hope I have been able to convince you and not confuse you tonight.